Now this is a question based on electrolysis. What does it say? How much electricity in terms of Faradays is required to produce what? First part is 20 grams of calcium from molten calcium chloride. If you have calcium chloride, that means you have calcium ions which you are trying to reduce to get calcium. If you want 20 grams of calcium, that means you have 20 upon 40, that is 0.5 moles of calcium. Okay. And as you can see from stoichiometry, 1 mole, you need 2 moles. So for 0.5, you need 0.5 into 2, that is 1 mole of electrons, which is 1 Faraday charge. Why? Because charge carried by 1 mole of electrons is 1 Faraday. That's it. Okay, that's that simple. Yes, it's that simple. But you did not use a formula. We don't need a formula. We can use simple stoichiometry for mole concept. But nobody want a formula. We are dying to use the formula. Let me give you the formula also, though I could use a method too. I have just solved this using basic common sense. But we can do it from method also using Faraday's law of electrolysis. Using the formula, in case you want to do this by a second method using blind formula, can we do that? Yes. And how's that? We'll use Faraday's first law of electrolysis. And what is that? What does that say? It says that mass of substance liberated or dissolved at an electrode W is MIT by NF. We have a formula. In our case, we have 20 grams of calcium. So 20 grams of calcium, its molar mass or atomic mass is 40. We know that. Into IT by N, 2F. Why 2F? Because N is equal to 2. There are 2 electrons being used. Fine. So what I get? I get IT by F is 20 into 2 by 40, which is 1. Which means IT is 1 Faraday. But IT is nothing but charge Q. So charge Q is 1 Faraday, or 1 Faraday of charge is needed. That's a very interesting and stupid way of doing it. But yes, if you are comforted by use of a blind formula, and there's nothing bad about it, you can do the second method also, although the first method is simpler, more elegant and very beautiful. Now let me do the second one for you. It says 40 grams of aluminium from molten aluminium oxide. So you have Al2O3 and you're using electrons and you're making aluminium and O2. Let's forget about oxygen, we are taking aluminium. There are 2 aluminium atoms, yes, and how many electrons? There would be 6 electrons. Actually, in fact, if I'm just writing half the reaction, I'll write 3 times oxide like this. This is only at cathode. O2 can undergo oxidation at anode, etc., etc. We are not interested. So this is the way we can write. Aluminium ions are being reduced to aluminium. Oxide ions are simply released in the solution. I need 6 electrons for that. So if you're planning to get 40 grams of aluminium, fine, 40 grams correspond to 40 by 27 moles because atomic mass of aluminium is 27. And 2 moles give you 6 moles. So 40 by 27 will give you 40 by 27 into 6 by 2, which is 3. So many moles of electrons. And 1 mole of electron is 1 Faraday here. So how much is that? So this is 40 upon 9 Faraday. How much is that? Let me just divide that. That's not a big deal. I think this is 4.44 Faradays. So 4.44 Faradays of charge is required in the second case. Oh my God, you didn't use the formula? If you want, I can do that again, no problem. So the formula would run like this. W is MIT by NF. W is 40 grams. M is 27 atomic mass of aluminium. IT by F will remain as it is. And N has a value of 3. Why 3? With 1 aluminium, you need 3 electrons. Please remember, whenever you are calculating N, if you are calculating N, I am giving you a very good tip. Please remember, if you are calculating N for aluminium, then change the coefficient of aluminium to 1. If this becomes 1, with 2 it is 6. If it is 1, this would become 6 divided by 2, which is 3. And that is why we are taking the value of N as 3. If you are trying to calculate N for any species, always in the balanced equation, use 1 mole of that species and see whatever is the number of moles of electrons or whatever is the coefficient of electrons, that is the value of N only for that species. So for aluminium, the value of N is 3. This is how we do this. Got it? Good tip. So IT by F is so much. And how much is that? So therefore, IT by F is 40 by 9, or IT, which is charge, which is 40 by 9 Faraday, which we got there also. Whichever way you love it, do it.